Hello, this is lesson 12-3, areas of trapezoids. Let's focus first on the parallelogram drawn on this page here. We know that the area of a parallelogram formula is base times height. So here's a parallelogram. I've outlined the base, I've outlined the height, and I've kind of drawn a line passing through the middle of this parallelogram to split it up into two congruent pieces. And each one of those pieces is a trapezoid, which I've drawn at the top of the page here. Now, probably most of you, when you think of the idea of trapezoid, think of an isosceles trapezoid, where the side lengths are congruent to each other, like this, and the angles are congruent down here, and the angles are congruent up there, okay? That certainly is a trapezoid, but that's a special case of a trapezoid. For all trapezoids, all that's required is that you have two lines that are parallel to each other, and then the other two lines are not parallel to each other. Because if the other two lines are parallel to each other also, then you have two pairs of parallel sides, and you have, in effect, a parallelogram. Okay, trapezoids, the way we define them for this course anyway, and most geometry courses and books will define trapezoids as having only one pair of parallel sides. But again, that doesn't mean that the other pair of sides has to be congruent to each other. They can be. That makes it an isosceles trapezoid. So these two figures at the top of the page really are trapezoids. They're just not isosceles trapezoids. They are congruent to each other, okay? They're congruent to each other. And I'm calling one of the parallel sides B1 for base 1, and the other of the two parallel sides B2 for base 2, okay? In parallelograms, we don't really have a base 1 that's different from a base 2. If you take this segment down here and call it B or call it B1, this segment up here is going to be the exact same length. And so we'd also call it whatever we call the bottom. But for trapezoids, there are two bases. Those are the parallel lines by definition. Okay, it's just the bases are the two sides of the trapezoid that are parallel. And they're going to be different from each other. So again, one I've called B1, the other I've called B2. Since this trapezoid here on the right is congruent to the one on the left, but I've just rotated it around 180 degrees, so the B1 is down here and the B2 is up there, okay? Now, if we slide these two trapezoids together, again, we would return to this parallelogram here. And we know that the parallelogram's area is this whole entire base times its height. But let's write a new expression for this base, a different expression, not just the letter B. Let's write an expression for this base in terms of the B2 here and the B1 there. Those two segments have just been slid together, haven't they? And so we could call this base down here, instead of just B, we could call it B2 plus B1, or B1 plus B2. It really doesn't matter what order you add two terms in. It's the same thing, right? And so now we can change the area of this parallelogram to be, in parentheses, B1 plus B2, and then times the height of the parallelogram. Well, the height of the parallelogram is the same as the height of each of these two trapezoids at the top of the screen, right? And so since there are two congruent trapezoids making up this parallelogram, each one of these trapezoids areas is exactly 1/2 of the area of that parallelogram, right? I mean, there's two of them congruent making up that whole parallelogram. So the area of either one of those trapezoids, the upper left trapezoid, the upper right trapezoid, is going to be 1/2 times the area of the whole parallelogram, B1 plus B2 times H. And so here then is a formula for the area of any trapezoid at all. It's going to be 1/2 times the sum, I'm sorry, that should be a B1. 1/2 times the sum of the two bases, which again are the two parallel sides, and then times the height. Okay. So there's one way to explain why the area of a trapezoid formula is what it is. Let's go look at some example problems. Okay, let me open up a new sheet here. Let's see. Go to the computer. Should have been more ready for this, but that's okay. Oop, remote unit 12. Here we go. So here's the problems we're going to work on today. Not too many today. Find the areas simply of these trapezoids by using that formula. Okay. So we have to identify the bases. We have to identify the height. Again, the bases are always the two parallel sides. So for trapezoid ABCD, the two parallel sides are AB and CD. How long is AB? 1, 2, 3, 4, 5, 6, 7. This one is 2. What is the height? The height is a segment that is perpendicular to both of the bases. Right? And if it's perpendicular to one, it's going to be perpendicular to the other for sure because the bases are parallel to each other. So where's the height? Well, we could draw it in lots of different places. I'll draw it in there. How long is that? 1, 2, 3, 4. And so the area of this trapezoid, 1/2 times the sum of the bases, 2 plus 7, and then times the height, which is 4. 1/2 times 4 is 2. In the parentheses is a 9. 2 times 9 is 18. There's the area of that trapezoid. How about this one here? The bases in the middle, again, are the parallel sides. That one's 3. This one is 6. The height runs, again, in a perpendicular fashion between both of the bases. And that's 1, 2, 3, 4, 5. So the height of this trapezoid, 1/2 times the sum of the bases, 6 plus 3 times the height. That's 9 times 5 is 45, times 1/2 is 22.5 square units. Okay. And then finally this one over here. How long is that upper base? 1, 2, 3, 4, 5, 6, 7. The lower base is 4. The height is 3. It really doesn't matter if you're wondering which base is B1 and which base is B2. There's really it doesn't matter which base you call B1 and B2. Okay, they are distinct from each other, but in the formula, they're being added together, and it doesn't matter what order you add things in, so it really doesn't matter which one you call B1 and which one you call B2. 1/2 times the sum of the bases, and then times the height, and there's my phone alarm. Excuse me for a second. Sorry about that. Let's see. 11 times 3 is 33, and then times 1/2 is 16.5 square units. Okay, fairly straightforward. Now, let's look at these two problems. Right, where I'm giving you some information about a trapezoid and asking you to find some other information. In neither of these problems am I asking you to find the area. I'm giving you the area. Okay? And as I said in my video lessons for circumference and for arc length, and I didn't say it, I don't recall saying it that much in the last video lesson for rectangle areas. But for circumference and arc length in this one, write down the formula that is related to the problem, that has any connection to the problem. Write down the formula or formulas, plural, that you're going to need first. That is a step towards solving the problem. Okay. I mean, if anybody was making mistakes in these circumference and arc length problems because you weren't writing down formulas, you're as likely or maybe even more likely to make mistakes with these trapezoid problems if you don't begin by writing down the formula. Okay, so problem number one, let's do that. Let's write down the formula. I know it just feels like copying, and for some of you probably feels like a waste of time, but I hope the more you follow this type of procedure, and it becomes more and more important the farther you go into mathematics, I think you'll appreciate the value of doing this. So there's the formula. Let's plug the information from the problem where it belongs. The trapezoid has one base of 30 and a second base of 22. Where do those go? Which one is the B1 and which one is the B2? Well, you heard me say just a minute ago, it doesn't really matter, right? So put the 30 in for B1 if you like, put the 22 in for B2, that's fine. And an area of 130 square centimeters. So that area goes in for A. And then it says find the height, okay, which is h in the formula. That's going to be the only variable left once we plug all of this information in. 130 is equal to 1/2 times h. Oh, by the way, it looks to me, hold on, let me finish writing this, times 30 plus 22. I'm seeing something that I did now here that maybe some of you caught me doing and wondered about. When I was finding the areas of these trapezoids here, did anybody notice that I put the height out here at the end of the formula? Whereas when I wrote the formula, I've got the height here between the 1/2 and the B1 plus B2. So that really doesn't matter. I mean, look, the 1/2 and the h and the B1 plus B2, those are three things that are all being multiplied by each other. And not only does it not matter what order you add two terms in, it doesn't matter what order you multiply terms in, right? 3 times 4 is the same as 4 times 3. 2 times 10 times 5 is the same as 5 times 10 times 2. So this trapezoid area formula can be written in several different ways. Okay. In fact, here's another way to write the formula. Let's write h times B1 plus B2 over 2. Could write it that way. Algebraically, that's the same thing as this expression. So I don't really care, what form of the formula you use, as long as you begin by writing it down, because that's going to be helpful to you. Write down the formula in whatever legitimate form, and then start doing some simplifying and algebraic steps in order to solve for the variable that remains. And there's a variety of ways that we could begin solving this purple equation for h. Again, I don't care what step you take first and what step you take second, as long as you're doing mathematically appropriate things and getting the right results. So my suspicion is most of you would probably want to add the 30 and the 22 first, and that would be fine. Okay, 130 is equal to 1/2 times h times 52. Okay, now at this point, there might be some variation in the steps that students choose to take. Again, because the order of multiplication of these three things doesn't matter, we could rearrange the order, put the 1/2 next to the 52, and then simplify by multiplying the 1/2 times the 52. And we would get 130 is equal to 26h. And now, of course, everybody would divide both sides by 26 to solve for h, and we would get that h is equal to 5. Okay, but let me recommend a different step. Instead of multiplying the 1/2 times the 52, just because I think it's going to be really useful in the next problem. Instead of multiplying the 1/2 times the 52, we could multiply both sides of this equation by 2 in order to, oh my gosh, how does my pen go? 2. In order to cancel out that 2. And then we would get h times 52 is equal to, what's 2 times 130? 260. And then divide both sides by 52, and you're going to get the same answer. Okay. In fact, we could have multiplied both sides of the equation by 2 at the very beginning and to cancel out that 1/2. So again, there's a variety of orders of steps that you can do to undo things and simplify things in order to get to the final result. The order of the steps you take is absolutely unimportant to me, or I'm sure to either of your other teachers. If you've got Ms. Rouser, Ms. Rusk, I'm sure they don't care either. Okay. Let's look at this next problem. A trapezoid has one base of this, a height of that, an area. Oh, okay. It mentions trapezoid. It mentions area. Those are your clues that you're going to need the trapezoid area formula. So again, let's write it down. 1/2 times B1 plus B2 times H. Where do things get plugged in? One base of 50. Which base does that go in for? Do we have the other base? Oh, no, we don't. We got to find the other base. So we've only been given one and we got to find the other. So which one of the bases is this 50? Okay, again, if you've been paying attention, it doesn't matter which one is the 50. Put the 50 in for the B1, put it in for the B2. It doesn't matter. Okay, the other base will be the variable that we're solving for. Okay, so I don't know, let's put the 50 in for the B1. Okay, a height of 18, no question about where that goes, and an area of 500 square centimeters, no question about where that goes. So 500 is equal to 1/2 times 50 plus B2 times 18. Okay, again, there's a lot of choice here at the beginning of this problem as to what step you want to take to begin solving for B2. I'll tell you what I would not do. I would not distribute the 1/2. That is a choice that you could make, but then you've got a 1/2 coefficient in front of the B2. I would prefer to get rid of the 1/2 rather than distribute it. And there's two ways that we can do that. We can either multiply both sides of this equation by 2, and that'll cancel out the 1/2, or we can multiply the 1/2 times the 18, because again, these 3 terms here are all being multiplied together, and we can multiply them in any order we want. We can only multiply 2 things at a time, right? I don't care how many things are multiplying together. You can only multiply 2 at a time. Even I can only multiply 2 at a time. Sometimes maybe you can multiply 3 things together so quickly. Certainly I can do it so quickly that it looks like, feels like, sounds like I'm multiplying 3 things all together all at once. But I'm not. I'm taking 2, multiplying them together and getting a result, and then multiplying that result by the third one to get a new result in so little time that it may seem like I multiplied all 3 at once. But I want you to know, I can't multiply more than 2 things at a time. And so that's what I'm choosing to do here. I'm multiplying the 1/2 times the 18 and getting 9. 9 times 50 plus B2. Okay. So now, again, I think a lot of the temptation for a lot of students would be to distribute the 9. I mean, students just like distributing. Anytime they see an opportunity to distribute, they like to do it. And there's nothing wrong with distributing when you have the opportunity, but sometimes you can save yourself a step by looking for a different thing to do. Okay. If it were me, I might distribute the 9 here, but I might divide both sides by 9. Okay. And I might resist dividing by 9 because I can see that I just know that 500 is not divisible by 9, and that's going to turn into a mixed number with a fraction, or it's going to turn into some decimal that I don't know what it's going to be. I'm going to need a calculator. Conveniently for me, though, I can do this division in my head, and I can come up with the exact repeating decimal. Okay. I mean, all you need to do is reach for a calculator. 500 divided by 9 is 55.5 repeating. Okay. And that's equal to 50 plus B2. Now all that remains to be done is to subtract 50 from both sides, and we get B is equal to 5.5 repeating. And there is our exact answer for the length of the other base. Now, again, I suspect a lot of students are going to want to distribute at this point right here, and that would be fine. If you distributed, you'd get 500 on the left is equal to 450 plus 9 times, let's see if I can move my face out of the way, plus 9 times B2. Subtract 450 from both sides. 50 is equal to 9 times B2. And then, see, you're going to end up dividing by 9 anyway, right? I divided by 9 at the beginning. If you distribute, you're just going to end up dividing by 9 in the end anyway. And so the distributing was really kind of an extra step. Is it a hard step? No. Does it take a lot of time? Not really. But, you know, we're always looking to shortcut our work as much as possible, right? And anyway, you're going to come up with the exact same value for B. One more time, write down the formula without anything plugged in first, right? Write down I was highlighting that and my pen turned off right in the middle of highlight. Write down the formula without anything plugged in. And then plug things in and write out the second line, okay? Like that. And then do whatever simplifying or algebra you need, okay? That's really the lesson here. This last one is a practice problem. We've seen these before. How many square feet are there in 48 square inches? Okay. Why don't you pause the video and do this right now? Pause it, do this problem, then restart the video. Go. Okay, so 2 ways to do this problem again. One way is to invent a rectangle whose area would be 48 square inches. You might come up with 6 by 8 or maybe 4 by 12. If it's 4 inches by 12 inches, and then you convert those inches into feet, you're going to get 1 foot here, and you're going to get exactly 0.3 repeating feet there, and then 0.3 repeating times 1 is 0.3 repeating square feet. Right? If you did 6 inches times 8 inches, 6 inches is 0.5 feet, and 8 inches is 0.6 repeating feet, and 0.5 or 1/2 of 0.6 repeating is still 0.3 repeating square feet. So there's one method or approach for doing the problem. Invent a rectangle with the dimensions that you need to come up with 48 square inches. Convert those linear dimensions, those length dimensions, from inches to feet, and then calculate the square footage. Or the other way to do it is to recall that you've got 48 inches squared. There are not 12 square inches in a square foot, but rather 144 square inches in a square foot. And so if you've got 48 square inches, that's not even close to a whole square foot, right? And so recognizing that helps you know that we need to take that 48 and not multiply by 144, because then we're going to get an extremely large number of square feet, right? We need to divide by 144, and that's going to come out to the same answer here, 0.3 repeating, okay? Good luck on the homework. We'll see you next time.